Okay.
Looks like we've got a critical mass happening, and more people will probably join us as time goes on. But I think now is a great opportunity to go ahead and get started. So today we're joined by none other than Dr. Venkata Pingali, and we're going to be talking about feature engineering, and feature engineering in the sense that it's not about what Google and Uber are doing with their feature engineering, but on a lower level than that. Well, not lower, just smaller scale, we could say. Medium scale is what we called it. And to start off, I'm going to say big thank you for coming and joining and talking to us, Venkata. I really appreciate
My
it.
pleasure.
And I wanted to start with something that I normally start with, and that's, can you give us an idea of how you got into tech and where did this all begin for you?
It's actually an interesting story. I mean, like I was mentioning a few minutes back, I went to grad school, going off thinking about distributed systems. My PhD was in that, and I got very interested in data shortly after I finished my postdoc, and I moved back to India. And for the past 10 years, I've been dabbling with it, with data. I was data scientist for a while, and then I switched back to systems for data science. And it's very interesting how it happened. I was heading data for a mid-sized consulting firm, which had a bunch of very interesting projects, a very large-scale marketing campaign. There was this nationwide food and beverage chain for whom we were setting their strategy and so on. So and it was happening at such volumes and pace that we were quite happy until the moment when we hit upon a couple of embarrassments, right? And that actually got me to focus a lot more on the infrastructure. All the while the focus was on speed and accuracy and those kinds of things, but the questions never arose about the correctness. Is it even true? Whatever we are claiming, the models, the analysis that we are sharing with our stakeholders, is it even accurate? So that questions had come up. And once I started focusing on it, I started wondering, why is it that our methods are not as sophisticated as our modeling methods? Because for the, if you go back to even software engineering itself, there's a 30-40 year history. We know that code that we write is buggy. And how come the same checks and balances don't apply to data science is a question that came to our mind, my mind in particular. And for the past 3-4 years, the focus has been on trust in data systems and systems that enable you to increase the speed while not giving up on the correctness issues. So our specific area of business activity tends to be feature engineering, which I'm going to spend more time talking about. But I believe that there is only one kind of data science, which is trusted data science. If you don't trust it, it's you can't actually make any serious decisions. Data science is one thing if the output is PowerPoint, and data science looks a little different if it actually impacts the business. If a CFO has to use your data science to reject customers, for example, because they're considered high risk and so on, which has an immediate business impact, the CFO is going to ask hard questions. Do I believe it? Does it run? Does it run today? Is it going to expose me to other legal and other kinds of risks down the line? These questions are, I think, inevitable. I think we are in the middle of the transition process where data science is moving from being a lot more lab kind of activity into something that is that other stakeholders in the finance and operations and government and legal and everybody can depend upon. So the I still remember the couple of embarrassments that we had in 2016 that got me down this path. And I think that with every, what we have noticed is that when we were talking about data integrity and some of these issues, there were hardly any takers in 2016. Now you just pointed to the ODSC talk that was actually very well received. There were like some 200 people who were listening to that whole conversation, where we are saying that it's not all the sexy stuff. Like you better get your discipline in your end-to-end systems. So it's an interesting journey where I went from systems to data science back to now systems, and this is pretty much what you know I intend to do for the next few years, and it will be really required. The guardrails are really required if data science has to grow.
Hmm. And so you spoke right now just about how you see data science. Can you go into that a little bit more? Because yesterday we had Flavio on, and he was
Yeah.
talking about his vision of the current state of data science and machine learning right now. And he was talking about how no longer can you have just one guy with a laptop writing
Yeah.
scripts. It's much more high stakes than that. And so I wanted to see what's your vision on that and how do you look at it?
So, at least, I mean, I've seen the domain itself grow. It went from being exploratory, nice to have, something that funky guys do, to something that is becoming a regular function in every organization. Now, I think what people did not sufficiently appreciate is what does that change actually mean? Imagine a CFO coming and you being accountable to the CFO. I think at least when we talk to clients, when we are talking, domain after domain, I mean, our work takes us, we have already touched like 6, 7, 8 domains. In domain after domain, there is a lot of clarity that every company needs to do data. In order to do data, it needs to have strong processes, teams, and infrastructure. Now, what we are in the middle of the phase of people figuring out what this actually looks like, what kinds of teams, what kinds of interactions, flows, collaboration, what kinds of infrastructure, what should the infrastructure actually do for you? How should you cope with the evolving accountability mechanisms, whether it is explainability or whether it is legal, whether it is GDPR and so on. I think we are in the middle of figuring out this process. This process will probably go on for another 3 to 4 years. Then, much like how today you cannot go to organizations and code without Git, there will be a standard set of processes, tools, methods that you will use. There will be checks and balances before anything touches the rest of the organization. And especially if it touches the end customers and it exposes the company to risk, the bar will be much higher. And I think what I find is data scientists seem to be somewhat they're feeling the pushback now from the community overall as well as from the organization. But I think it's a good thing. You cannot go around experimenting with people's life. Now we are using data to impact real lives. So the in particular, going back to my own embarrassments and experience, right? Here, there was a large marketing campaign where literally my data would move 100 people this side or that side. And it was a very risky field activity that they were doing. So you can't say that it is a purely an Excel or a Pandas activity. I don't know what happens in the rest of the world. Data scientists need to be held accountable for the job because there are real life side effects of whatever they do. Now it's a matter of whether the community as a whole can develop the appropriate processes, tools, frameworks, thinking, and principles to be able to achieve. MLOps, in some sense, is a mix of two things. One is that, in my opinion, it's about standardizing some of these processes. And along with that, some of the principles, manifestos, and the articulation of how this should be done is an equally important cultural artifact, in my opinion, that will shape the community as a whole. And it applies to the end-to-end life cycle. The reason I'm also in this MLOps conversation is that when you're thinking about day-to-day use of ML, it doesn't stop with just the model development. That is one step in a long process. We look at, as part of the data preparation feature engineering, we look at another step, but the same principles applies to you also, right? You are also accountable. Every explainability question of the model has an implicit explainability question on the underlying data also. And from here, if we have to move one step, further upstream, there will be equivalent questions that we would be asking to the developers and the data engineers also. So trust, accountability, these are end-to-end attributes of systems that we are going to build. So I think that all of this is good, is part of the growing up and part of demystifying and making the whole thing engineering-like.
Yeah, and maturing as a
Mature.
whole.
Absolutely.
And the more and more we talk with people, the more we hear that it's standardizations need to be put in place, and they're starting to form, but it's a few years away maybe.
Yep.
And yeah, I really
there will be,
that's quite.
My original grad school experience is from the standards body, right? I think that there will be, formal standards as far as data representations and those where there can be clear boundaries, but there will be de facto standardization in the form of tools. Tools will embed. For example, Git is a de facto versioning standard, right? Nobody said that Git is what you should do, but that is the language that everybody uses. So we foresee that there will be standards for metadata, there will be standards for data, there will be standards for interfaces between systems. Even within the system, there will be more room to play around. Otherwise, interoperability will become a very big issue. For example, I can tell you immediately, right, the interoperability issue that we see. We do feature engineering. We generate data sets that data scientists, analysts, as well as data applications pick up. One of the important immediate questions is to know who is using what feature, because there is a cost associated with feature. It's a very computationally intensive. We have to pay money in terms of effort, the time, memory, every operational cost. So naturally, the question will be asked as to who is using features and why are they using. And the first integrations that we did was to MLflow. And MLflow did not have this idea that they have to send back information to the feature engineering system about which feature is being used when and why. So we had to artificially inject it. So I expect that at these kinds of intersection points or interface points, there will be new standards and interfaces. MLflow cannot just use this feature, because it also needs to know where did this data set come from, right? If it has to provide lineage and reproducibility and so on, you can't have just the model reproducibility without having the data reproducibility.
Yeah,
so there is that interface.
And seeing that everything needs to play nice with each other, right? They
Correct.
need to know what, and ultimately for the end goal, to be able to say, okay, this is where we want to go, and so we need to know all of this. So
until now, most of all of these systems were built in-house by tightly knit teams that were sitting next to each other. Now, as the data science and productionization spreads around, you won't have that luxury anymore. You will have to, for example, nobody's building their own model database. Either it is Dotscience, or they will use MLflow or some equivalent. And the enterprise complexity will very significantly increase if there are no standardized interfaces.
Yeah, that's a great point.
So I think it will happen.
So pivoting a bit to your day-to-day, what, because you're the CEO of Scribble Data right now, what does your life look like as a CEO? Are you still writing code? Are you still doing that kind of stuff, or are you more on the business side?
Yeah, I do a bit of both. because I think that there are very interesting, right? We provide a tool to the end customer, but one of the things that we realize that the customers actually want from us is also our language of thought. How do we think about the end-to-end data systems and processes? They want their teams to hear our point of view and our recommendations. So I end up actually spending quite a bit of time talking to the end data science teams. Although I don't get involved in the models themselves, I think that they like the fact that we take this whole area very seriously. We have a point of view, and we have an understanding of the best practices in this, in the domain. So I end up spending quite a bit of time on the development and almost the same amount of time talking to customers and helping them in the journey, right? It's not very uncommon for me to sit down with the data science teams and review their not the output, the overall process to achieve the discipline. See, you can't you can't, if there is a customer of ours who is buying our product because we say that our feature engineering system has lots of nice attributes like reproducibility, auditability, and all of those things. You cannot have one piece in a puzzle being reproducible and other pieces are not being reproducible. That doesn't work. So they have to harmonize and align the rest of the pieces, whether it is the data collection piece or the modeling piece, to be consistent and achieve the overall end-to-end objectives. And this is still somewhat of a new area, and we, even though we don't ask them, the customers have encouraged us to be a lot more prescriptive, encouraged us to tell their teams to be, to organize their work a certain way, simply because we have the opportunity to see many companies and many groups.
Yeah, and it makes total sense. You don't want one thing to be very shiny and nice, and then the rest is put together by a string and it's not working and you have problems with it. So
Correct.
I can see how that would work.
And consistent with what Flavio was saying, right? All of this is high risk stuff. Let me give you a concrete example to help understand the situation. See, there's a customer of mine that actually is taking inventory bets on the products. They have to decide whether to keep 9 units or 50 units of a certain product, and for that they have to do forecasting and understand the demand and so on. Now, it was recently they started noticing some unusual behavior of the models. Then when they started investigating, the first thing that they go to is the modeling code, the scikit-learn, whatever code, and the Jupyter notebook, and from there they start tracing it back all the way. And it turned out that what was happening is that the Java application code that was there which was the source of a lot of this data, they made some implicit decisions about how to handle products from some geography and not from, and how to handle products from a different geography. There was some element there, but this end-to-end debugging process, they struggled to debug actually what was the model that was actually put into production, right? The precise code, because the code itself was moving very fast. When they were able to come to the Scribble platform itself, whose work ends at the data set generation, from here we could go back and say this is exactly what what our sources of the data was there, because as a matter of routine we keep track of the metadata, we have a lineage search, all of those kinds of things. It was clearly apparent that you cannot have this end-to-end debugging ability with black holes in the middle. And in this case, they were able to find they had logged the data set that they had used for the modeling. So from there, we were able to chase it down to the Java source and then fix it. And it is not, this happens actually quite frequently. So I believe that reproducibility and explainability will be driven not so much by the asks of third parties like regulatory authorities, but just because you have the need to understand and debug your own data science systems that you have built. If you don't understand what bets it is taking, when and why, you won't be able to manage the risk.
Wow, that's really thought-provoking. The change will come from the internal side as opposed to regulations.
Correct. So initially, when we were, so we started out by saying we need a little more structure to this data preparation. That was our limited idea. But with every passing day, as we kept on hitting more and more of these situations where we have to know who has computed what, when, and why, right, to enormous amount of detail, the platform became, we started adding more bells and whistles to just to be able to do this. So we had reproducibility before it was a sexy word, and that something that everybody today watches for, because for us it was very interesting, right? The customers, there were several customers who said that I want data as a service from your platform. I will just, my interface with you is just the data. If I have problems with the data, I will come to you. And just to be able to service that kind of a contractual interface, we had to build out this reproducibility and even add things like checkpointing. So for example, let's say you found that there was a bug in the code. You have to know when was this bug introduced, how many days back, so that you have to do the backfilling. Even if you even if you know when it started, in order to correctly understand how the bug you know uh, propagated through your particular data preparation system, you need to be able to have an ability to checkpoint. What is to you need the ability to know what was the state of the pipeline at a certain point. In order to do that, reproducibility, checkpointing, metadata logging, all of these just came.
Wait, can you say that again? We just lost you.
So I was saying that reproducibility, the checkpointing, metadata, standardization, all of these just came out of the need to have confidence in the data, because that was our business model. We told people that if you come to Scribble, you will have confidence in your data. You will be able to audit your data at any point in time. In order to service that kind of interface, we had to develop a set of capabilities that today have words like reproducibility and so on. There will be a few more that will come down the line. One of them is, I believe, metadata. Metadata will, because almost all of these functions revolve around knowing what, where, when, and why, right? Of a given piece of data frame or data set on the disk or anywhere else. So we'll have a lot more conversations around metadata. We'll have a lot more conversations around data quality, because the moment you say that I want to have confidence in my data, you need to have confidence in the raw data from which you are picking up. So one of the early use cases which came as a surprise to us is just as a quality monitor for your existing data sets. So monitoring will be a big thing, in my opinion, because without that, you cannot guarantee quality. Without guaranteeing quality, you cannot guarantee trust.
Yeah.
And without trust, you cannot provide the explainability and all the nice features that you want for your modeling.
Of course, of course. And in your ODSC talk, one thing that I found to be something I had to think about was this idea of models, biases in models that you have are coming from biases in the data sets. So it goes back to that idea of your model is only as good as your data.
Correct. As the modeling code is standardizing and being baked into all of these libraries, that piece is becoming more and more predictable. The piece that is unpredictable is the data on which it is being trained. that is the one that drives the behavior of the model itself. So I expect that trust in data as a concept will be more important as going forward. And I can give you a few different examples from companies that we have interacted with, which tell me that this is the way it will go.
Yeah, that'd be great.
So, okay, let me give you this fantastic example of this guy who was working for a large e-commerce chain, who was essentially, his job was to set the prices of SKUs on the website. And they had 2 million products on their site. And this guy has a very complicated LP to determine the optimal pricing for every single product. And so naturally we go there, we pitch to the company, and the company says, no, we have this wonderful ML system, because it was a well-funded startup and so on. They have large teams, and they said, you go away. Like, we're all very happy with what we have. Then later, this gentleman comes and meets me. Not after the ODSC talk, there was a talk, similar talk before that. And he says, you please come, I need to talk. I said, your teams are very happy. What is the problem? The problem that he said is that every time my revenue on the site goes down by about 2 to 5%, I get a call directly from the CEO, right? And I cannot communicate the pressure I feel to the rest of my team. My team spends 3 weeks building the LP, and then I optimize it, look at it in output, and then put it into production. But I have this nagging feeling that mess up has happened in the 2 weeks, and I can't put my finger on where the mess up has happened, how it has happened. So I need control over the part that is feeding my LP. Can you come talk to my team? Can you come talk to my
were they using something already? Do you remember what they were using?
All the standard tools. I mean, this is a Python shop with PySpark and a bunch of things, right? I think that the problem is not so much on this, what I think of as the compute building blocks, right? Even if it is PySpark, you need to know what is going into PySpark, what is coming out of PySpark, what did you do with it, right? And are you doing a quality check before it goes in and after it comes out, after the data comes out? So those are all things, those were the control plane around the Spark was the one that was missing. And this is not a very, if I were data scientist, I would be very, very nervous. I mean, this is what made me switch from data science to building out the robust systems, because you cannot build defensible models until you have a robust underlying system. And it's a mix of tools, technology, processes, and so on. But I don't, many times you are just playing, you're somewhat blind to all of these issues until, it becomes a situation where you are getting a call from the CEO, right? That is when because before that, if you go and ask for resources to be able to build out this kind of guards and rails, I'm sure the CTO and others would have said, this takes too much time, we cannot build it out. And it just takes 1 or 2 disasters for companies to realize that there is only one kind of data science, which is a dependable data science. And dependability is not a very straightforward attribute. You have to build out the appropriate tools, processes, infrastructure. So I like the last couple of talks, and actually the last 3 talks. In various ways, they're touching upon these kinds of issues: the importance of the team, the importance of processes, and the personal discipline, and the tool to enable the personal discipline, and so on.
Yeah. So hopefully it doesn't take 2 disasters for the company to learn. Hopefully they don't even need 1. But yeah, some people are stubborn. So
yeah,
there
was Money had a question. They had some really nice.
I think it was more of a
yeah, it was a comment. Yes, more and more discussion is happening, Money, on this particular topic. I expect that there will be a lot more going forward. Now we have entire conferences on some of these explainability and so on. That is the sexiest end of the whole story. I think that slowly that conversation will propagate to the rest of the, down the stack, including to humble places like feature engineering.
Well, in that ODSC talk that you gave, you had a slide that showed about the infrastructure, and it showed how it was different rectangles, and each rectangle was a different size, right? Depending on how much time you put onto the time you put into that to be able to create this model in production. And the actual model building was a very small rectangle when it came to the rest that you needed to think about. And I'm wondering, can you go into that a little more in depth?
It's become very famous. So this, one second, let me, how do I, no, I can't. Yeah. I think you are referring to this piece, this particular thing. If folks are not familiar, there was a very interesting, somewhat controversial paper that was written by Google team in 2015, where they were downplaying the idea that ML is the only thing, and that they were pointing out to how much other infrastructure around the ML that they had to create. And initially, when we were doing feature engineering, our idea was this: that it's actually a linear process. You just feed the model with your data. We will have DSLs. We'll make it very easy to create new and newer features and so on. But we went around searching for alternative ideas because our understanding was breaking down in reality. We were finding that we had to do a lot of monitoring data, lots of data quality, lots of resource management and so on. And we kept wondering, how is it that our understanding is not jiving with that linear model? That is around a couple of years after this was published, in around 2017 or so. We found this picture, and I think this is a much more realistic reflection of the kinds of effort that goes in. And as feature engineering problem, as feature engineering platform, right? Even this feature extraction is one box here. Our experience actually suggests that we pretty much touch most of these boxes, including a little bit of the serving infrastructure itself, because if you want to get end-to-end confidence, you have to make sure that you are verifying the data. You are planning out the resource, because all of these feature computations are very, very compute intensive. We have checks and balances of various kinds, and we also have efficiency improving mechanisms. And I think my sense is that this picture reflects a somewhat of a realistic distribution of the effort. Now, the particular form that this distribution takes in different companies at different scales is very different. So that's where the mid-scale comes into the picture. The distribution of this effort, the particular tools and the processes that each of these box maps to, will look very different in Google compared to everybody else. And one of the things, when we think about this, we asked ourselves, what are these pieces trying to achieve? And we see that there are basically 4 objectives that this entire system is trying to achieve. The first one is speed. We know that more models will be built, more analysis will be done. The question is, with every, can we add use cases at sufficient enough speed? So standardizing, simplifying, and automating is a big objective of this whole thing. The second one is that when we have these models proliferating, we have to have confidence that they actually work and work every day, and you actually know what is happening. So bunch of the infrastructure is to give us confidence that this is a reasonable infrastructure. We can stand in front of the CFO or whatever is whoever is the stakeholder and be able to defend the system. The third one, which came as a little bit of surprise, which I would suggest you folks to take away with, is that we used to think that models are built once and then they go into production. They're like that for a little while, and before we look at it again. Now, what we find is that the speed with which all of these pieces are evolving is actually much, much faster than we realize. And therefore, if you are not building for continuous evolution of the system and debugging this system as it is evolving, you probably will face growth bottlenecks. The growth bottlenecks will not come because of the scale of the data, but really the scale of because of the growing complexity of the entire system. And the last one is, of course, we want to model ever larger number of customers, products, and so on. That some of this has to do with just planning for scaling out all of these things. But my strong recommendation is that you should definitely read this paper. There is a follow-up paper which talks about tests that a system, end-to-end system, has to pass. That is, I find that also very useful to think about all of these things. And when companies, the companies that we deal with are mid-sized, 20 people, 30 people kind of data teams. They have a mix of folks. We see that it will be a significant challenge going forward to take all of these pieces and stitch them with the limited resources that you have. So,
and
yeah, go ahead.
That's perfect. For anybody that's wondering, we can send them these slides. Is that correct?
Absolutely. I'll share the slides on the on this thing, and of course, a much longer discussion is in the ODSC talk. That also can happen.
Yeah. So as a follow-up, I'll send you all the slides. I'll send you the ODSC talk, and then we can also put a link to this Google paper and the follow-up one. And then if you're listening on the podcast, we'll put it in the show notes there at the bottom. So
okay.
I think the next question that I had was circling around this idea of the difference between small companies and big companies and their needs.
Yeah. We definitely see. So for a long time, I was wondering, the Ubers of the world have been putting out their systems and architecture. And my field experience has been very different from that. And I kept wondering, why is that the case? Why is it not looking like Uber-like system? And then what I realized is that even in the narrow subspace of feature engineering, it's actually not one design point. It is there are at least 6 or 7 design points. That means your feature engineering system could look like one of 6 or 7 different possibilities, depending upon the scale of your data. For example, if you look at the feature engineering system that was open sourced by Gojek, there you will find a very clean DSL to specify a feature. And then they have an entire system to execute the DSL. Now, the reason is that they made their data actually looks very tall, which is it has 10 columns and probably 10 billion rows. Whereas a lot of my customers' data will look like 5 million rows and 200 columns, because a lot of them are in the retail and other spaces with fairly complex systems. So the point here is that this space, people are still figuring out this space. What is the appropriate design point for your size and complexity? The other dimension, for example, that makes a lot of difference is how closely is the feature engineering tied with the actual modeling. Deep learning, for example, combines the two, and the separation point is not very clear. So those systems will look very different. But I had this strange meeting once at an NVIDIA, meetup, where the NVIDIA folks were also saying, why don't you build some feature engineering systems for deep learning also? So there is a hint that somewhere there also, there is a need to factor out the whole data preparation part and treat it as a somewhat of a separate full-fledged activity shared across many models. So, but we haven't had enough experience in that to have a point of view on whether it can be done or whether it should be done and so on. What is very clear to us is that by the time you cross about 8 or 10 models, 10 different use cases, you'll start needing for a standalone platform that is shared between all of these 10 models. Otherwise, the complexity will grow very fast. Just the sheer amount of confusion between the definitions of these features itself will bring you to a slow down or a halt. You say that for example, what is likely to happen is, for example, you say that the margin is so and so. The next data scientist would say margin is something else. That is enough for the conversation to, for the development to stop, because the organization needs to have a consistent definition of a feature, because the impact of it is just too high if you get if there is confusion on that those variables. So what we are seeing is that featuring as a standalone, you start off even if it is a single data scientist and a single model, you start out as an integrated activity, both modeling, feature engineering, data collection, everything. And then as you scale up one after the other, a clearer boundaries emerge. And our original clients used to be $1 billion, with massive teams and things like that. We are finding that our conversations today are with very early stage startups where they are thinking, already planning from day one for a scalable productionization process. So they want it. They want many models to be put into production. So they're talking to us earlier and earlier in the journey.
Yeah, we've been seeing that too at Dotscience, that people come with the vision that they want this reproducibility before they get into all this technical debt. I think that's a great point, and smart for these guys. They know what they're doing. So
yeah, I
just
think.
go ahead. Go ahead.
No, I was just saying that I definitely would like to see lot more thinking, deeper thinking from the platform owners and the data scientists, because what I have noticed is that when we go around deploying across many companies, we encountered a variety of situations. There are lots of corner cases, lots of blind spots, and correcting from all of them is very expensive. For example, one of the things, the thing that keeps me awake at night is that when you think about these data preparation pipelines, right? There are, it looks like a DAG themselves, the pipelines themselves, one pipeline feeding another pipeline, and so on. Now, the if you are wrong with respect to, if you're off with respect to the definition or the correctness of one of the variables, leaf level variables, right, feeding this entire DAG, your data science for the past 6 months, 8 months will go out of the window in a jiffy, one instance. So if you are not thinking through and very carefully planning every step, you're likely to make mistakes. See, if data science was simple, right, productionizing, everybody would be productionizing. There is a reason why only a tenth or a 20th of the models actually go into production, because when they in the process of going into production, you start realizing that there are lots of these hidden assumptions, bottlenecks, and issues that have to be sorted out. So it is better to think through those things even before you get into the modeling phase.
Completely. So we got a question from Mani in the chat, and I also want to take this moment to open it up to anyone else who has any questions.
Is it a question or a link?
So there's the Q&A part too. There's the chat, and then there's also a Q&A. And the question is, I'll read it out so that if people are listening in and they don't see the chat, they can understand. So is it a good idea to have multiple sets of feature engineered data sets in case of conflicting or multiple overlapping features? What's a good way to handle such situations? Great question, Mani. Thanks for asking that.
Yeah, so it is actually quite commonly observed where there are adjacent use cases. My other use case just differs by these three features, right, from the previous one. What we have ended up doing in all of these cases is doing a multi-step feature engineering. So you can either, if the available feature set works directly for your use case, use it. If it is not appropriate, go one level deeper, and the previous level of featured data sets you can use. And we have typically about before the end user sees the final features output, we have partially computed information at least at 5 levels. So you can go to the fourth level or the third level. And sometimes people go all the way to the first level if the information needs to be, we need to crawl the raw data again and get some additional information. It happens very commonly with, for example, the click streams, where we know that we need one more attribute from the click stream that needs to be propagated through the entire system. So the answer is at least what we have ended up doing is that plan for a multi-level. Every use case starts with whichever is the level that works out best for them, and then build it from there to avoid rebuilding.
Great, great. So you all have talking permission, I believe, and if anyone wants to just open up their microphone and ask the question, you can feel free to do that. I see there's another question in here, and it's asking, does the multi-step feature engineering involve brute force, combination, permutation, or some smart mechanism to select features, groups of them for, e.g., genetic algorithm or other statistical methods could be used to gain insight into features to select?
That's a good question. We have been so most of our conversations in our deployments are with the data scientists at the other end, and with the growth of auto ML and so on, we kept asking them, do you want feature tools, integration with the feature libraries, and automated computation of these features? And the answer that came back almost consistently is that we have an idea of what features we would like to see, right? And they went great fans of all possible permutations being available, and them looking up what is appropriate. In almost all of the cases, the features are pull based. That means the use case is driving which features get built, when and why. And the reason is actually very simple. In most cases, we are dealing with fairly complex data sets, and it is not easy to build these permutations, combinations. For example, just one pipeline of one customer generates an feature matrix of 400 million cells. You cannot have 10 of those 400 million cells, right? So there's some mix of data scientists having a point of view on how the features should look. Second, computational complexity and the cost associated with keeping computing all of this. And the third one is probably that even with the existing features, if they are able to use the features, I would be happy. I think the problem is not that we don't have adequate data. The problem is that we are not sufficiently deeply thinking about the data sets that we have ourselves, not sufficiently exploring, not sufficiently leveraging the signals that are already available.
Perfect. So I've got a question. I know we're starting to get to the top of the hour. It looks like maybe there's one or two questions left. What is your opinion? How do you feel about orchestration tools like Airflow or Kubeflow? What are your thoughts on that?
Yeah, we have our platform integrates with Airflow. Sorry, not it used to interface with Airflow. Now we do Prefect. Now, to us, the reason we had to build our own DAG was we needed a workflow at the granularity of a data frame that is inside the process. So all our deployments have a combination of Prefect for cross process workflows, and an intra-process workflow that is our own, right? But by and large, I think that the main challenges in this space is not so much the workflow orchestration tool itself, but really about how do you structure your development process and the modules and everything else to achieve the end objectives. So they play a role, but they don't play a very central role, in my opinion. And Kubeflow and things like that, again, I have mixed feelings about it simply because Kubernetes is very complex, and most of my customers, at least, don't have the financial resources to be able to set aside dev teams and ops teams to run the Kubernetes. So we have stuck to you know simpler deployments.
Great, great. So if anybody else has a question out there, feel free to unmute yourself and ask away. Otherwise, I've got one last question. I'll give it 5 seconds for silence to see if there's a question, and then I'll shoot.
Hi, can you hear me?
Yeah, we can. Perfect.
Perfect. I was wondering, is it possible to use your system for like trial basis, so that like non-subscribers or non-paid customers can play with it and then sign up to your services, or is it only for paid services, so we can see how your end-to-end workflow works?
Yeah, why don't we take that? I'm happy to discuss with you offline. But the short answer is that it's a developerish tool, so there is it's not a simple deployment. But I think that we'll figure out something that works for you.
There you go. Perfect. Now, last question, because next week we're going to have Alex Spanos on, and he's going to be talking about what being an MLOps engineer entails, and more about where the roles of an MLOps engineer, a machine learning engineer, a data scientist, a data engineer. And I'm just looking at, from everything you spoke about, this fluid definition and what you feel falls into one category and what you feel falls into the other, and how that looks in your mind.
Yeah, I don't have a point. I'm not arrived at a point of view on MLOps engineer versus ML engineer. I have little more clarity on ML engineer, data engineer, and data scientist. Right now, if you look at our conversations with at our customers, for all practical purposes, we don't talk to data engineers. We don't talk to anybody who's delivering, the Kafkas and ETL pipelines and things like that. Our work almost always seems to start after they are done with their work. So there is, in my opinion, clarity there, and almost 90% of our conversations is with the data consumers, data scientists or analysts, and so on. So ML engineer needs to understand enough about data scientists to be able to speak the same language. On the other side, they need to be able to talk the data engineering language, because much of what we deal with is systems issues. But if you don't appreciate the modeling process and all the complexities and the nuances associated with it, a ML engineer cannot do their job, because their ML engineers customers are the data scientists. And I don't see data scientists entering the ML engineering very easily. And the reason seems to be that in order to build good ML engineering systems, you need to have very strong systems background, dabble with lots of different tools and services and JSONs and whatever, all of those dirty details, right? Unless you're building systems, you wouldn't do it. A lot of the data scientists have not built application systems, right? So when I look at the code that is written by data scientists, half the time I have a heart attack, right? Because it is, uh, you know, forget explainability. I can't. It's not even readable, right? Most of a lot of the time. I mean, there are very smart guys, but production readiness is not exactly their strong suit. So I see the need for ML engineers, strong systems background, but sufficiently in-depth understanding of data science to be able to operate. Now, within that, how much of it is ML engineering development versus ops is a separate thing. I think it will look more and more like the ML data ops, like this other gentleman on the same forum was talking about. We'll come up with new words. They're not yet there.
Perfect. Well, last thing before we go, I want to mention to everyone, I'm putting a link in the chat because we have a Slack channel, and we'd love for you to drop by, where we talk about anything and everything MLOps and ML systems. The other thing is that today at 5 p.m. UK time, we're going to have open office hours. So that's a place where anyone can jump in and talk about the systems that they're using. And if they have any problems, hopefully the greater community can help you figure out how to work through these obstacles. And the last thing is, this is a weekly meetup, so please join us next week. We have a new speaker every week. I know this week was a bit different because we wanted to incorporate the Far East time zones, and so we had it on Thursday morning at 10 UK time. I know some of you are in India and Japan, wherever, so it's a little bit later there, but normally we have it at Wednesday, or on Wednesdays at 5 p.m. UK time. So if you can make it, we'd love to have you. And if you can't make it, you can check us out on Spotify. We put all of this onto a podcast form and also on YouTube. So if anyone wants to go back and look at all the talks that we had, you can see that. Otherwise, thank you for joining us.
One last
please
point.
do.
First of all, thank you to Dotscience and Demetrios and Luke and all of those folks. I think this community is required. The conversations need to happen because there's a lot of clarity that needs to be obtained over the next few months and years around all of this. And the community, I mean, I joined when it was probably a few dozen people. Now it is already over 200 people. I don't think it's an accident. I think that it will take all of us to contribute ideas to this forum, I think.
Yeah.
So I would encourage people to come, and I'm also on the now I'm regularly checking in once every 2 days or so on the forum. So I think you should find me there as well.
Yeah, it's great to have your voice in there and your knowledge and experience. So we give you a big thanks for being part of the community. And thank you all for listening. We'll see you next week. Have a great day or night wherever you're at. Take care.
Thank you. Mani, I'll get in touch with you separately.